Okay, folks, last one for the day, and then obviously you guys can go play in the ice and snow and do whatever it is. Good luck sleigh riding in this stuff, or sled riding, or sliding, or sledding, or whatever it is that you call it, depending on what part of the region of the country you're from. By the way, hopefully you didn't go out and steal milk and bread and eggs and all that stuff like other folks do. I want to talk about power functions. Okay, I'm going to be talking specifically about the powers. I'm going to be talking about the function itself being even or odd. I'm talking about the powers of the function, the highest degree power of the function being even or odd. So, if the power of the function is even, then we know that we're occupying quadrants 1 and 2. If the power of the function, the highest degree of the function is odd, then we're occupying quadrants 1 and quadrant 3. Okay? Quadrants 1 and 2, quadrants 1 and 3. So in other words, we're always going to be occupying quadrant 1, and then depending on whether or not it's even or odd, we're occupying quadrants 2 or quadrants 3. Why? We're doing that because simply, when we have an even power, say we have x squared. If we have x squared, then you take a negative and you square it. Well, negative times negative is a positive, so even though the x is negative, the y will always be positive. So even when the x is negative, to the left of the origin, our y is going to be positive, so it means it occupies quadrant 2. If we have an odd function, say negative 2 to the third, now you have a negative times a negative, which gives you a negative power, or a negative number. So as we move to the left of the function, you are still going down, which is why it occupies 1 and 3. Okay? So that pertains to whole numbers, but that also pertains to fractional powers. Now, when we talk about fractional powers, this is where we get into differences. Yes, odd powers are x to the 4th, x squared, x to the 12th, something like that. You are also talking about odd powers over here, like x to the 3rd, x to the 1st, and something like x to the 7th. You know, those are odd powers. Okay? But an even power, when we're talking about what quadrants they live in, could still be something like the square root of x, which is x to the 1/2. So in this case, x to the 1/2, we're looking at specifically the denominator. The denominator will dictate whether or not it's even or odd. So if you have an x to the 1/3, that makes it odd. So that means, once again, it occupies quadrants 1 and 3. And then square root function will occupy quadrant, square root function will actually only occupy quadrant 1 unless you have some sort of horizontal shifting that takes place. Okay? Special cases. What do I mean by special cases? Well, if I have something like x to the 4/5, okay? So you're thinking, okay, well, fifths. So if I have fifths, then that makes it odd. So that means that it occupies quadrant 1 and quadrant 3. However, because my numerator is even, that means that this is the 5th root of x to the 4th. That x to the 4th means that if you have a negative x, you're multiplying a negative by itself 4 times, which makes it positive. So when you have an odd denominator, but you have an even numerator, this one will occupy quadrants 1 and 2. Okay? Hope this was helpful. If we don't have school tomorrow, expect more like this. However, I'll probably be at my house because driving in today apparently was a little crazy, but crazy. Have a good day.